interest of getting started, it lies with me to welcome you to the first in what will be a series of webinars that have been organised by the University's Birmingham Plastics Network. I'm Andrew Dove, I'm a member of that network, and I'm also a Professor of Sustainable Polymer Chemistry here at the university. The network is something that we've put together to pull together the interest in plastics from all over campus. It's an interdisciplinary team of over 40 academics that brings together chemists like myself, but with environmental scientists, philosophers, engineers, linguistics, economists, artists, writers, lawyers, and many other experts in many other fields. Because what we want to do at Birmingham is holistically address the global plastics problem and see it as a challenge that needs all of these different inputs to do just that. And today we've got a representation from across campus of several different areas, including a guest with us from Reckitt Benckiser, that we're grateful to have with us, to hopefully spark some debate and thought. And this particular session will focus on the plastic life cycle. So we're bringing together experts from industry and academia to do this, and we'll start with the plastics life cycle today. There's going to be plenty of opportunity for a Q&A session, and specifically we're going to hold a single Q&A session at the end of the panel meeting. So each of our panelists, who I'll introduce as we go through into their presentations, we've got a short presentation. Feel free to enter a question in the chat function or the Q&A function at any time, and we'll come back to what we can get to at the end of those presentations. So I've spoken for long enough already, and what I want to do is allow you to hear from our experts that we've got assembled. And so I'm going to ask our first panelist, Martin Settle, to share his screen and begin his presentation. Martin is the Global Research and Development Packaging Sustainability Manager at Reckitt Benckiser, and so I think he'll bring us a really interesting viewpoint on the plastic life cycle. Martin, over to you.
Hello everybody, my name is Martin Settle. I've been asked to speak on sustainability packaging and consumer trends. I'm the current manager for polymer science packaging for sustainability, and previous to that I was the global packaging sustainability manager for Reckitt Benckiser. So hello to everybody. There's a lot of misconceptions about who's to blame and who's responsible for the environmental waste. My view is the consumer has My view is the consumer has a stake in the waste and the plastic waste that is being generated. It's not solely the responsibility of industry, although industry plays a big part. There are also other players in this field, NGOs and media, who are giving information out, retailers who stock the product and sell it, and then legislation. And there's lots and lots of legislation that is driving changes. What this actually means is that companies like mine are setting ambitious sustainability commitments and targets, and we're developing new strategic partnerships across the range of industry, from research and universities all the way up to retailers and consumers. Who should be taking the lead in finding improvements in solution? So this is a report that has been done externally by Tetra Pak, and is one of many reports that are available on the internet, but this one is specifically around packaging. As you can see, government are playing a major role in what is going on and driving the changes from a governmental point of view. Food and beverage companies, packaging companies are also a major implications in this, and are being targeted by the consumer as the people who should be taking responsibility. But also the consumer needs to take responsibility for finding improvements and solutions. We can't do it all, and we don't make the choices about what the consumer buys and what the consumer puts in the waste. So this is really to show that there's lots of people interested and lots of interested parties that are interested in the discussion. And yes, the fact that people want government to lead it and industry to lead it is great, because we are doing. but also the consumer has to play their part, else we can make the world's greatest packaging or plastic. The government can legislate for it, but if you still throw it in a river, you throw it in a river. So all industry, regardless of source, is now heavily focused on looking at future ideas for packaging and how we get there, the building blocks to get there. The real drive is to move away from fossil-based plastics, so crude oil and single-use plastic, and move towards materials that are solely made from renewable and recyclable packaging materials, ensuring that they're wherever possible, and not everything is possible, but wherever possible, everything is fully recyclable, and that the emissions, especially when it comes to CO2, are as low as we can possibly make them. Now, the reason we say renewable sources and fully recycle is because it takes these products away from going to landfill and incineration, and it secures the environment against environmental impact from these materials. So you're looking at renewable packaging, so packaging that can be either used more than once, or can be, the material from it can be used multiple times to make different materials, and making sure that everything we do is sustainable, has a minimum impact on the environment. There is a big push towards a circular economy. Circular economy is really good, but there needs to be a lot of education to the consumer and governments to make sure that circular economy works and that people are recycling the right products in the right way. And that as industry, we design products that can be recycled in the right waste stream. This is a step in development and is going to continue growing and developing over the next 5 to 20 years, and is really the start of the journey to build the infrastructure, to build the recycling. But it has to go hand in hand with education, because if the consumer is not educated and picks the wrong product and disposes of it incorrectly, we can do all this work for nothing. And actually, the consumer can put something into a waste stream that ends up contaminating the waste stream, not making it recyclable. So I just wanted to give you a bit of a look at how, as industry, the timescales involved, the work that's going on in the background to develop new products. So as you can see from the timescale, we've got lots of new product developments out there, and this is just a snapshot based on some of the work that Tetra Pak did. From biodegradable caps, which are now nearly 10 years old, for fully recyclable cartons, to cartons with antiseptic on the outside, materials and cartons and bottles with biodegradable coatings, from materials that have barriers that were thought to be recyclable and biodegradable aren't, to fully renewable sources that actually come from organic feedstock, so things like sugarcane, banana leaf, and sugar beet, and are now looking at being renewable, removing fossils. There is a cost to this technology. There is a cost to developing this technology, and it is not commonplace. It is becoming more commonplace, but that cost has to go somewhere. At the moment, it's going to the consumer. So the consumer has a choice whether they need that material or want that material, and whether them as a consumer are prepared to pay the additional cost to have a fully recyclable, environmentally friendly product. This is to give you an insight into use of recycled content. Now, we could have picked any product here, but I picked a cardboard box because everybody knows what a cardboard box is. Every cardboard box has recycled material in it, else it wouldn't work. It's not getting the recycled material into the box that's the problem. It's getting the right recycled material into the box at the lowest risk in the right grade that is the problem. And what you can find, and what is demonstrated by this slide, is not everything works and not everything can be put back into primary packaging, and some things will have to go into secondary packaging and be downgraded. And it's the same whether we pick a plastic bottle, whether we pick flexible film, whether we pick glass. All of them can be recycled to a certain extent, but not all of them can be reused for primary packaging. So again, the recycling chain and the circular economy are putting the right thing in the right recycling stream and giving the consumer the right information to make the right choice and place it in the right stream is vital. What we do as industry is help the consumer make these decisions. So what we do is help by designing in recyclability and end of life into the products we sell. So instead of just simply thinking, what's the cheapest bottle we can get and the cheapest material that does the job, which is the old way of thinking, and making it as light as possible, we now still want it as light as possible because we're reducing the material we use, but now we think, is it recyclable? Does it have a circular life? Can it be designed for reuse? And every company, every major PLC across the world now has sustainability requirements and pledges aligned to NGOs, aligned to government requirements and legislation. And I want to take away the myth that we're sat on our roles and being forced to do it. We're not. We're constantly developing new materials. We're constantly pushing the envelope on sustainability and the environment. The problem with most of these things, there is an uplifting cost, and we at some point will end up passing these costs on. And at some point, somebody will have to make a decision on where these costs go. And until these products become the norm and become the mainstream, there is always going to be a cost implication to this. But we are developing new monomaterials, new single-use plastics that are fully biodegradable, compostable, recyclable, new materials from alternative feedstocks, tall oil from forestry, and organic oils and fungi. But also we're ensuring that there is a full supporting life story behind everything we do, and using life cycle technology and digital solutions to support the assumptions and data and conclusions that we come to. So when we do something, it's validated, it's proved, and it's shown to where it will stand in the life cycle and how many times it can be recycled and what effects it will have on the environment. So talking about current packaging regulations, basically this is what everybody thinks. There's no enforcement, the guidelines are vague, help. All we're interested in is lightweighting. There's different packaging rules across countries in the EU, and it's difficult to understand. This is basically the way it was. And what has happened is there's lots of legislation to bring everybody in line. And there's lots of governmental pacts and regional laws now being brought in to get away from all this nonsense about regulations and all the requirements. We have very strict regulations in the industry governing what materials can be used for what products. We have very strict regulations about what products are hazardous and what aren't. And we have now another layer of commitments, which is about what materials we use and how it is disposed. So there's lots of talk and lots of work going on about solving all these problems in the most sustainable, environmental way friendly, but aligning all the while to the new regulations, new directives, the new laws that are being passed to make us more environmentally friendly. So this is the essential requirements. This is what's coming in law, and it has been passed in law and is going to be coming through all countries within the EU and starting to be spread across the world. As of today, we have an essential requirements that we have to meet to be which is a legal requirement for all sorts of things, including tax and waste. The essential requirements will start to be implemented from next year. And this will be defined even more in the rules, and come 2022, the rules will be enforced. The rules are going to be increased, and there's all sorts of taxes and fines and requirements made now on industry, which will start to escalate further up to 2030 to ensure that we are responsible for the waste we generate, that we are responsible for any contamination of the products that we generate, and that the material we do use is the most sustainable form. This is just a snapshot. It is not the full list by any shape, but it's just to give you an idea of the timescales involved. And this is the one that is fixed in law. There is a further projection on this up to 2050. And if we'd have gone back 5 years, there'd have been legislation, work and laws to get us to this stage as well. So this is just to give you a snapshot of the regulations and laws that are coming in force now for industry, which affect our choices and affect the decisions we make to supply to the consumer. This doesn't only affect manufacturers. This also affects retailers and the choices that retailers make in the products they buy to sell you, the consumer. This is an example of what Tesco's have done. Tesco's have introduced their 4Rs program: remove, reduce, reuse and recycle. And basically they've laid out the law to say, we want to be more ethical when it comes to sustainability. We want to be clearer with the message to the consumer, but also we want to be one of the forces driving change through the manufacturing chain. But also they want to mitigate the effects on them financially from not doing this. When you go to Tesco stores, you will see signs like these up. They are promoting what they do. They are promoting the 4Rs. They are promoting the message. This is good for them to do because they are a driving force in consumer choice. But also, it's a legal requirement under the new directives in the EU and across the world that we have to educate and communicate clearly the recycling message. So you'll start to see a lot of the big retailers doing this. You'll start to see a lot more on pack doing this, and the message will become clearer and clearer and clearer. This is all about making sure you as a consumer have the right information to make the right choices, to pick the right products, and to put in the right waste stream. So Tesco's have initiated the 4Rs program, and they have pulled together a red, amber and green list of plastic materials that they want out their business. Now, this is just an example of some of the plastic materials and products that they want out of their system and out of their stores to help the consumer make the right choice. So as you can see, there's all sorts of materials there. I'm sure you're shocked by some of the products and what they contain. But basically, tablet blisters, a majority of PVC based. That's because it's cheap, it's durable, it makes all medical requirements to have a tablet blister. It's strong enough, but still poppable. And it does all the things that we want on the tin. There is not a viable replacement for PVC at the moment. And it is a medicine, so the restrictions placed on a pharmaceutical company are huge to make sure that whatever we pack it in is inert, that it does the job it's supposed to do, which is protecting the goods and making sure that the pharmaceutical inside works and is not affected, and that the product that we change it to has no adverse effects. So there's lots of regulations that govern some of the decisions we make, and some of the things that are on here will not be overnight successes. There will be lots and lots of work in the background to make these changes happen. So this is an expansion of what Tesco's are doing, and Tesco's are not the only ones doing this. All major retailers are doing this. To show you some of the background work that's going on to move products from red, amber and green. Green are products that are accepted, are recyclable and have no issues with being in the recycling chain. Amber are products that have question marks over. And there's lots of products out there and plastics that have question marks over that either need verifying that they are green or need confirming that they are red and need removing. So this is a constant process backwards and forwards between red, amber and green of materials to make sure that they're as sustainable as possible. One thing I wanted to point out is black plastics are not the devil. One of the components in black plastic is the devil, carbon black, because it contaminates the waste stream and gives false readings. But black plastics are not the devil, it's just a component part of it. So again, that is about consumer choice. Consumers making an informed choice, not a choice that's based on half-cut information that's out there. And this is the green list. So this is a list of products that are acceptable by the big retailers. This is Tesco's example again, that are highly recyclable, that have a second life and have been thought about from the end of life. All we do is design with recyclability and efficiency in mind. We design to make products as recyclable as we can. And if we can't make them recyclable, we make them reusable. If we can't make them reusable, we make sure that they do no harm or limit the harm they do to the environment. Now we can do all this work and manufacture products from the most environmentally friendly products in the world. But if the consumer still makes the wrong choice or is ill-informed and picks up a bottle or a cap or a product or a pack of crisps and still throws it on the ground, I can't do about that. The parting line I'm going to send you is, you get all these things about things in the sea, the oceans, the rivers, etc. Those products didn't commit suicide and dive into a river. A bottle does not walk itself into the sea. Somebody drops it on the floor. And that's a consumer who drops it on the floor. So thank you very much for your time. Really appreciate the opportunity to talk through my views on packaging and the consumer aspect of packaging and plastics. Education is the key. More understanding is the key. And making sure that we as manufacturers are tuned to what the consumer wants, but also make sure that we confirm that we are designing the most sustainable products we can within the constraints of the regulations, laws, and rules that are out there. So once again, thank you very much for your time, and I appreciate it.
Martin, thank you very much. We're going to move now on to Natasha Cornea. Natasha is a University of Birmingham lecturer in human geography. And Natasha, I'll just hand straight over to you to tell us on your viewpoint on this.
Great, thank you very much, Andrew. So my research largely examines environmental politics and urban governance, primarily in South Asia, though I've done some work in Zambia as well that I'm going to draw on today. And it's really about thinking about how urban environments are governed and controlled, and the politics, particularly of solid waste management, that the plastic problem intersects with my own research. And today I really want to suggest that by framing plastic waste as a problem to be eliminated, we really risk, I guess, focusing on technical fixes and overlooking the people who are already involved in managing this problem. Particularly when thinking about plastic waste in the global south, we risk marginalizing a whole host of actors in southern cities, including waste reclaimers, or what's often referred to as waste pickers, and informal and small-scale recyclers, who through a wide range of practices provide really a crucial yet undervalued service to cities. And I want to suggest that to effectively and equitably address the challenge of plastic waste, particularly in the global south, we need to incorporate these actors and their contributions both into policy and socio-technical interventions. In short, that we need to live up to the belief of a recyclables broker in Lusaka who assured me that these people at Lusaka City Council know we assist them. And the photo here is of the Lusaka landfill. So, to try to get my slide to go, which of course, there we go. So there's a lot of risk in a short talk like this of lapsing into really broad generalizations, when in fact the realities of how plastic waste in particular becomes a livelihood resource in the global south varies quite significantly. And I want to illustrate that with two kind of examples here. So my research in small cities in West Bengal revealed kind of multiple and diverse points where recyclable materials are diverted from waste streams. High value materials, things like metal and glass, are often diverted at the household level. Whereas relatively low value and bulky materials, particularly plastics, things like bottles, discarded flip-flops, and packaging, really enters the waste stream where it's removed by waste reclaimers at community rubbish points, and later directly at the landfill, like you can see on the left-hand side of your screen here. So that waste at the landfill is collected and sorted by reclaimers into quite finely grained categories. And this relies a lot on the skill and embodied knowledge of these laborers before it's sold on to brokers, who often then further subdivide this waste into really, really remarkably fine categories in order to sell it onwards to recycling firms and their agents. So in India, waste reclaimers are estimated to remove 1.5 to 2 kilograms of plastic waste from the waste stream per day per reclaimer. So already you can get a sense of just how much they remove from the waste stream. And it's estimated that across India, about 60% of plastic waste plastics are recycled. So it is a fairly significant contribution. That pattern, however, is quite different in Lusaka, where I've also done work on waste workers. And there, during my research, almost no plastic was diverted at the neighborhood level. Rather, plastic waste, and particularly plastic bottles that you can see in this photo of the Lusaka landfill, are removed from the waste stream only at the landfill. So at the Lusaka landfill, female waste workers, and over 75% of the registered reclaimers at the Lusaka landfill are women, collected bottles from the rubbish that made it there. So those bottles were then sold by the sackful, and you can see these quite large white and green sacks here, to, again, mostly female waste brokers, who then in turn sold those on to an entrepreneur who shredded them and sent the shredded material abroad to be made into fleece, which was later resold on the Zambian market. So informants both at the landfill and those working for local aid groups indicated that this relative dearth of reclaiming was because of quite unreliable and poorly developed value chains in the country. And this is something that the reclaimers told us about as well, in that it was inconsistent. They currently had a market for it, but in the past they had kind of lost that market. So I don't know of any industrial ecology work done in Zambia to estimate the amount of plastic that these waste reclaimers are able to remove from the waste stream. But across sub-Saharan Africa, it's estimated that only about 9% of plastic is recycled. So it's quite a significantly less rate of recycling than what we see, for example, in India. What is common, though, across these cases and other research that I've read, particularly when there's been no intervention into this sector that sought to exclude people from the work and exclude them from accessing these resources, is that those who rely on plastic waste as a livelihood resource are amongst the most marginalized urban laborers. Waste reclaiming really has quite low barriers for entry, right? So it's not something that you need a lot of capital or any capital really to do. So it is often a way to provide a much needed source of income for those who have access to no other work. And it's one that can help households to ride out economic shocks. So I've chosen some responses from people I've interviewed here to illustrate that. So for example, a female waste plastics broker in Lusaka explained to me that after her husband's death, the business that they had, which dealt with metals, went down. She lost a lot of capital, so she had very little money to buy metals from people and sell those on. And so now she's dealing with bottles. That's how she made the switch. Quite poignantly, a waste reclaimer in Navsari in Gujarat in India simply stated that garbage is free for the poor, and it is one of the few things that is. And while it is often this kind of livelihood of last resort or a livelihood that you fall back on, there is dignity in it and there's life in it. A male recyclables broker in Lusaka spoke about the stigma and the pride of the work they do, pointing out that others assume we are mad and suffering, he said. But when they come to the landfill, they see that there is life here. So despite the potential to support the survival of some of the poorest in the city, and the scope for the lucky to progress from reclaimer to broker, for example, establishing more viable businesses, and quite crucially, businesses that they'd want their children to follow them into, unlike reclaiming, it's important that we obviously don't over-romanticize this work. It's often stigmatized, the earnings are limited, and the work itself is dangerous. For example, respondents in India pointed out that there's a significant risk of contact with medical wastes in cases where those had been illegally dumped. While my respondents in Zambia more often cited fumes and smoke from the fires that burn, smolder kind of deep in the landfill as being a key risk of the work that they do. I think we can probably agree that recycling isn't going to save us from the problem of plastic waste. It's not the long-term solution here, but arguably it's going to remain part of our strategies for quite some time to come. And thus, I want to suggest that really any equitable solution to plastics needs to consider these actors. It needs to account for the ways they contribute to mitigating the problems of plastic waste. It needs to valorize their contributions. But in doing so, I think we also need to kind of deal with the at times thorny social and environmental justice issues that such valorization raises. And what I mean by this is questions like, how do we incorporate actors such as these into our solutions without in turn creating unnecessary barriers to those livelihoods? How do we avoid, for example, unintentionally facilitating a shift wherein those who've traditionally worked in the sector or relied on the sector are now excluded from it in terms of that's not how I wanted to say it, are excluded from it in favor, rather, of those with more social, human, and economic capital. And if, for example, we formalize recycling, where it has been traditionally informal and multi-actor, how do we already incorporate those already relying on waste for their livelihoods and already acting within that kind of system into new ways of working, new ways of dealing with waste? And eventually, ideally, how do we help to facilitate shifts to new livelihoods when these livelihoods become obsolete? So really kind of complex questions, but I do think that these are questions we need to think of from the beginning and incorporate into our kind of any solutions that we offer. So that's it from me.
Thank you very much, Natasha. Some really interesting, thought-provoking questions you challenged us with there. So, as I said at the end of the previous presentation at the start, please do start to fire your questions into the Q&A, and I'll make sure we reserve some time at the end of this webinar for those. We're going to move swiftly on to our next speaker, who's Professor Stefan Kraus, who is a professor of eco-hydrology at the University of Birmingham. Stefan, I can see your slides up there, so please take it away.
Thank you very much, and thanks for having me and having us. I'm going to talk about some work that collaborators at Birmingham and Lyon and Vanderbilt University and I've been doing on the accumulation of plastic in river networks and the fate of plastic pollution in river networks in particular. So why river networks? Rivers are often seen as a major source, and they are a major source of plastic pollution to the oceans. But in addition of being a major source of plastic pollution to the oceans, where pollution has been tracked and traced for the last 2 decades and has received a lot of attention, river networks themselves can not just act as a conduit for plastic waste and mismanaged plastic waste, but we see a lot of accumulation in rivers and river networks, both in the surface water as well as in the sediments of rivers, underneath rivers and beside rivers. And that's where plastic stays very close to us. Plastic waste stays very close to us, and it has an impact. It's basically very close to the start of many of our food webs that affect us directly. It also has a potential. I'm going to show you some very recent results that we're just about to publish there, that to create a legacy. So we always talk about plastic as an emerging pollutant, but what is only emerging is our awareness of plastic as a pollutant of plastic waste as a pollutant. It has been out there for a couple of decades, and even though we see increasing concentrations in the environment, that has happened for a couple of decades already, and we have created a legacy that will outlast us for several generations. And I'm going to show you how we can identify potentially hot spots as well as hot moments or periods of pollutants that help us to target mitigation options, whether that's for cleanup or for reducing the problem at the source by reducing really the inputs into the environment. I start with some modeling results, and really at a global scale, where it has been identified that roughly 5 to 12 million metric tons of plastics are discharged by rivers into the oceans every year. These million metric tons are really difficult measure to understand. So 5 million metric tons is roughly 1 million elephants. That's a big one, it's African elephants. So we discharged, that was data for 2010, so it's already 10 years old. In 2010, we have basically discharged the equivalent of the weight of 10 million African elephants in plastic to the oceans. That is more plastic than have been detected in the ocean, because it's really difficult to detect, in particular the smaller particles, the microplastics in the oceans. Only 2 weeks, well, 3 weeks ago now, there were 2 papers published in Science that projected that up to 2030, so 10 years ahead from now, this will raise, even with our best intentions, to likely more than 50 million metric tons. That has not even included the rise that we see in single-use plastic uptake since March this year, or February, March this year, for both in the medical sector as well as household sector for of course use in the pandemic. That's not even included there. So we see still increases in the amount of mismanaged plastic waste, not just plastic use, but mismanaged plastic waste. However, if we compare that numbers, that's the waste, the mismanaged plastic waste that rivers are transporting to the oceans, that's still just a fraction of the mismanaged plastic waste, and Natasha talked about that before, that is produced on land. We know that 2010, when up to 12 million metric tons of plastic were discharged by rivers to the oceans, more than 120, oops, it's going the wrong direction, more than 120 million metric tons of mismanaged plastic waste have actually been produced. So where are they staying? Well, we did run a model. You see the outcome here. The red spots are where you see significant accumulation of plastic, mismanaged plastic waste on the land surface in river catchments. And we have been tracking that plastics for river catchments, for big catchments like you see for the river Ganges here, or you see for big Asian rivers from the Yellow River to the Mekong and Red River. A majority really is accumulated of mismanaged plastic waste in river catchments in Asia and Africa. And very interestingly, when we think about how to tackle that pollution, if you look on the lower left slide here, a lot of that is actually accumulated in quite some distance to the ocean. And that's really important when we think of when does that plastic actually reach the ocean, and how long does it stay in river corridors, and what impact can it have in river corridors until that is happening. So the majority is not produced only in coastal areas, basically because many mega cities are not that close to the coastline. Some are, but many are not. I show you two results for some of the main plastic polluted catchments in river catchments in the world. On the left-hand side, that is the Mekong River. Both of them are multinational rivers, so there are lots of issues with water management across boundaries. And you see that the input of mismanaged plastic waste, these are again values for 2010, was around 50 megatons. The output was just over 1. That means roughly 97% of plastics has been stored there for more than a year. For the Ganges, that's where we are working quite intensively with Indian partners. We see similarly values, so roughly 90 million tons gone in, a bit more than 2 gone out. So again, 97% stayed in the Ganges for more than a year. And that's really important because that defines for how long plastics can accumulate there and can actually cause harm to freshwater ecosystems, and of course us as end users of that water. One reason why it stays so long is that the majority of large river catchments are heavily managed, so the flow there is heavily managed. And that has an impact also on when we make predictions ahead into the future. You see again for the Ganges and the Mekong here, these are what we have observed and remodeled as a plastic discharge from that rivers out to the oceans. This is how discharge to the oceans will appear if we stick to 2010 values, and the blue lines are showing you basically an extreme scenario. What would happen if we stop any input of mismanaged plastic waste into that rivers right now? And you see that we see a sudden drop, but then a very long tail with still plastic basically bleeding out for easily up to 100 years from now, which we already stored in that river catchments. However, I have to highlight, these are all model results. We try to validate our models as good as we can, but models are very uncertain. And the first rule in modeling is, in this case, literally rubbish in, rubbish out. So models can always only be as good as the data that we use to run them with. In order to provide really good modeling data, what we do in Birmingham is we run what is called the 100 Plastic River Network, where we are working with people around the globe to actually create good observational networks for plastics that are stored and transported in surface waters and in river sediments. And then we run in our artificial river on campus a lot of controlled experiments, what's happening to that plastics, how are they leaching contaminants, etc. We have been rolling that out for the last 2 years. We are getting swamped with samples coming back from all over the world. And very excitingly, we managed to tackle plastic pollution in some of the largest and most polluted rivers globally. These are results and pictures here from a survey that we have done last year in the end of November, early December, together with partners from the UK and India along the river Ganges, monitoring plastic pollution basically from Haridwar, the upper Ganges down to Bangladesh, and where we are able to start identifying hotspots of plastic pollution in rivers that can help us, for instance, to pinpoint really where would cleanup operations be most successful, during what times is plastic pollution the highest, so how can we protect water sources from pollution by plastic from further upstream. There's a lot of work to do here, and our work is supported not only by a whole range of funders, research councils in the UK and in Europe and in the US, but also through some charitable funding campaigns in Birmingham. Andrew is involved in these as well, and everyone else can. So these are networks that are based on whose success is based on the contribution of many partners. And I just welcome everyone to chip in here, get in contact with us, and see how you can be involved in this as well. Thank you.
Brilliant. Thank you very much, Stefan. Some slightly terrifying, if not interesting, numbers you presented there that hopefully will stimulate some discussion later. The chat questions are starting to come in, so please do keep them coming. We're going to hand over to our final speaker of this session, who is Jonathan Saville, who's a professor of formulation engineering at the University in Chemical Engineering. Jonathan, I will not take up any of your time. Please take over when you're ready.
So, I'm a chemical engineer, and I'm in a group of a number of chemical engineers in Birmingham who are working on the plastic processing problem and how to turn plastic into something that realizes the circular economy. And we're working particularly with a company called Recycling Technologies, and it'll become clear what they do. I want to focus on some possible solutions, and particularly on a solution called pyrolysis, a solution for how you might convert waste plastics into something useful. So here's 3 possibilities for thermal treatment of waste. If you simply take mixed waste plastic, you see in the picture there, then there's three possible thermal treatment directions you might take. Starting on the right-hand side there, you could just burn it, not recommended. I won't go into why, I think it's obvious. In the center, take some oxygen out and heat. And if you get the conditions right, you can gasify the plastic waste and make a gas which contains a mixture of various things, but particularly hydrogen, carbon monoxide, carbon dioxide, a syngas. And you could pipe that somewhere and you could use that for heating or turn it into something else. That's a possible solution, and some people are working on that whole area. And then on the left is the area that we have been more concerned with, which is pyrolysis, heating without any oxygen, which then breaks the plastics down into hydrocarbon chains and produces something which is a bit like the oil that it might originally have come from. Pyrolysis, chemical decomposition of organic material at elevated temperatures in the absence of oxygen, from the Greek pyro, fire, lysis, separating. I like that. So how might you do this? Well, you could just pack your plastic into a pot and get the oxygen out somehow and heat it up. And indeed, there are various, even very small devices that are advertised, which enable you to do that even on a household level, I guess. Not likely to be thermodynamically very advantageous and probably not very good for the environment either. Here's another solution. So this beautiful animation, which I thought might brighten up our dull morning, dull as far as the weather's concerned anyway, it shows fluidization. So this is an area that we also work on quite a lot in Birmingham. If you pass a gas through a particulate material, which in this case is a sand-like material, it bubbles a bit like a boiling liquid. And this is a perfect environment into which to put your plastic waste, which is then intimately contacted with a hot sand-like material. You get good mixing, good heat transfer, and it's a very good type of reactor. So let's take one of those. In principle, you just feed your plastic waste into here and you get some useful hydrocarbons coming off. However, this process requires heat. How are you going to get it? Well, the solution that recycling technologies have is a so-called two-pot design, where you have a thermal cracker, you see on the left there, which is the endothermic process. You have to supply heat to that. That's where the cracking of the plastic is going on. And then on the right, you have a regenerator and you circulate your sand-like material between the two. What's the regenerator? Well, that's another pot in which you heat the sand up again and return it to the cracker. How do you heat it up? Well, you could burn some of what you're producing from the pyrolysis process itself, and that's what the recycling technologies process does. But there could be other ways of doing that. And for instance, if you've got essentially free energy from wind power, you could be using that. We could talk about that later if there's time and people are interested. So is this fiction? Not at all. This is definitely a real operating process. Here it is actually 4 years ago at on Swindon Borough Council's Municipal Waste Recycling Centre. And this is a plant which takes 700 tonnes per year of mixed plastic waste. By that I mean the stuff that's in your bin, and puts it into a hot fluidized bed and turns it into a useful range of hydrocarbons. However, 700 tonnes per year isn't enough to be really practical commercially. And what Recycling Technologies has done is to develop a 7,000 tonne per year plant, shown schematically here. You can see the two pots, the first one into which you feed the plastic where the pyrolysis is going on, the second one where the sand is being reheated and returned to the reactor. And then the other things you see there are devices to take out pollutants, which we can come to. and some fairly traditional chemical engineering distillation columns and so on to separate the hydrocarbons into a range of things which would be useful, described here as chemical feedstocks. And from 7,000 tons per annum of waste, you get 5,200 tons per annum of chemical feedstocks. And here is a simple schematic of a 7,000 ton per year plant, which is currently under construction in Ayrshire in Scotland, funded by Zero Waste Scotland. And the thing just to note there is, if you were going to do this seriously for the UK, you'd probably need about 200 of these plants, which is kind of similar to the number of really large municipal waste recycling centres, not surprisingly. And we could debate for a long time how big is the right size for a plant like this, because clearly it needs to be local. This is not the kind of thing where you're going to have 3 or 4 of them like you might have national refineries, for example. So what you see there is the various components are inside what's called ISO containers. So they're prefabricated in a factory and delivered to site as pretty much whole processes which are stuck together like Lego. To go to the bigger picture then, what you want to realize is a circular economy here. You've got plastic products coming in the left, you're using them in the home, you're throwing stuff away, it's being collected. Some of it is sorted and sent for mechanical recycling, which is your first choice thermodynamically. Some of it is going to what's in the center there, the RT7000, described as a feedstock recycler. That's the term that the industry uses because it turns it into feedstock for other things. And you can see other things being rejected here, like water, char and ash, heavy metals, halogens, and so on. We could, as I say, we could talk some more about that. That's important. And then that produces your hydrocarbon product, which could go directly to a refinery or could be transferred into some other kind of manufacturing process, where again you may have removal of pollutants, which refineries are very good at actually. And the result of that can be your virgin plastic again, which can be used again to make a plastic product. So that's your circular economy. And to show it a different way, if you look on the left, this is the situation right now that plastic is 12%, this is in the UK, or something like that, it goes into mechanical recycling. Pretty well zero goes into what we'd call feedstock recycling, sent back to the polymer manufacturer as a substitute for oil, which means 88% going into the things you don't want. On the right here, then you've got something which we think is realizable, where you might reduce that to only 10%. You do a lot more mechanical recycling, and you certainly do quite a lot of what we've called here feedstock recycling. So that's, in a nutshell, what we're working on. And of course, there are all sorts of issues about what I've just said, which I expect people will want to pick me up on in the chat. That's it from me.
Thank you, Jonathan. A really great overview there. We've got some questions coming in, and we will do our best to answer some of them. I want to start with a question which I think is probably most appropriately phrased to Natasha, because it came in immediately after your presentation. So it's quite an interesting point of view, says the question. What is the plastic split in household on developing versus developed countries? I was thinking along the same lines myself in terms of where is this waste coming from that you're seeing in these developing countries?
I think that's a good question. I don't have numbers for developing versus developed countries. We do know from various studies that have kind of quantified the waste stream, particularly in cities in India, which is probably the bit of research that I'm the most familiar with, is that the amount of plastics and other recyclables that make it into the waste stream are significantly higher in neighborhoods that have higher incomes. So relatively little going into the waste stream in low-income neighborhoods, quite a bit going into the waste stream as kind of income rises. So I'd expect that we would see a similar pattern globally or kind of on a per country basis. Obviously with some variability of how well established recycling programs are. I'm kind of shocked and appalled by Jonathan's statistic that only 12% of plastic is recycled in the UK. So yeah, but I would expect that we would see kind of similar patterns with the composition of waste.
Thanks, Natasha. I think that a lot of these discussions highlight that there's an awful lot of work to do, and hence, you know, one of the reasons for the Birmingham Plastics Network being in place is to help us address these. Stefan, did you want to come in on that point?
Just a very brief one, because there sometimes is a perception that low and middle income countries are the main sources of plastic pollution, and a lot of plastic pollution enters the environment there. But we need to be honest there, probably as well as consumers, that a lot of that plastic pollution that is entering the environment there has not been generated as pollution over there, but it's been pollution that basically be traded over there. And China just closed the doors to that, I think 2 years ago or so now, but that caused a shift further southwards, basically to Southeast Asia. And of course, the majority of our consumer good productions is not happening in Europe or in North America anymore, but over there. And that means that a lot of production, particular fashion and textile industry, is happening in Southeast Asia, where we see this huge waste burden as well. And maybe to a degree, luckily, that also means that a lot of the companies involved there, and we made really good experiences there, for instance, in Vietnam, where fashion industries really wants to be part of the solution and helping to reduce the plastic waste burden to the environment. But it's not all domestic waste that is produced by people over there. A lot of that actually is produced by us or for us.
Thanks, Stefan. I think that's a really important point to make. Jonathan, you've attracted a lot of interest in the questions. I'm going to pick the most controversial one to go with first. So the question is, don't you think that technologies that transform plastic into usable product is politically dangerous? That might give plastic pollution an incentive, especially keeping in mind that both production and recycling, downgrading, uses considerable energy on one side and politically incentivizing plastic use on the other side. What's your response to that, Jonathan?
Well, okay, so I think it's a very complicated picture. There are a lot of things we need to do. We need to stop using plastic in areas where it's inappropriate to use it. But I think stopping using plastic completely is not likely to happen, and probably isn't what we would want to have happen either, given the beneficial uses. So you've got to find some way of generating a sustainable economy in plastic use. And what I'm sure the people at Recycling Technologies would say is you're substituting for virgin plastic being made directly from fossil fuels. So there are, of course, environmental advantages in doing what I've described. I think something like you're saving something like 2 tons of CO2 per ton of waste plastic recycled, if you can do it this way. Is that an incentive to people to use plastic more? I suppose the economics come into that, and I can't help thinking that plastic is going to become more expensive, actually, and it probably should be more expensive, because we need to factor in the kind of environmental considerations that we've talked about, and that would act as a disincentive to increase its use.
Thank you, John. I think that's some really interesting points raised there. If I may throw my own 2 pence into this discussion, that a lot of plastic products were invented to help the environment, the plastic bag being one, that it has a lower environmental footprint until we dispose of it, at least, than paper or even cotton. So there are environmental benefits to using plastics because it's light, because it's cheaper, because it's, you know, it's less energy intensive to recycle. But a lot of these factors get lost and forgotten about when we look at the environmental impact of our poor disposal of that plastic have on there. So, you know, potentially better recycling of plastics actually reduces our need for fossil fuels and reduces our environmental impact of any other material as well.
Yeah, I agree with you absolutely. And I think an important point I should have made is that you shouldn't do any of these things without a thorough life cycle analysis to work out what the net consequences really are of what you're doing, including substitution of products. Because a lot of the solutions that sound obviously right are actually not right when you do the sums.
Thank you. We are running out of time, but Martin, I hope you're still with us. I can't see you on my screen, but we've got a question that's come in for you that I'll pose. Hopefully you'll be available to answer. You say that consumers are at the heart of everything you do, but considering the failures highlighted with our plastic pollution and recycling rates, should you place the environment at the heart of your decisions instead?
The environment plays a part, but who puts the rubbish into the bin? Who drops the rubbish on the street? It's not the environment. Plastic bottles don't commit suicide and jump into a river. It's people. So if we don't bring the consumer on the journey, the environment's not going to happen. Simple as that. Because the consumer makes that decision to drop it on the street, to put it in the bin, to buy that product from the shelf. So the consumer is central to that environmental story. If they don't understand it and are throwing things away that they shouldn't, or not making the correct choices, the environment's on a loss anyhow.
Thank you. I think that's a really important point you make. I always say plastic's not the problem, we are. Of course, plastic is part of the problem, but we're probably a bigger part of it. I'm going to try and squeeze one more question in here, because I think there's some fascinating discussion, and probably it's more likely that Martin and/or Jonathan might want to come in on this. But what focus is there on reducing the complexity of plastics, i.e. the mixed material? We have medicine blister packs, plastic plus foil, that are ubiquitous. Black plastic food trays, you try saying that in a rush. Household recycling don't collect, even the humble Pringles tube. What's your comment on about the complexity of plastics that we produce and use? I don't know if Martin or Jonathan, you want to come in on that?
I think the easy thing is, it's historical. We've gone back 20 or 30 years to where the push was to reduce. And by doing that, we invented new plastics and new applications for them. The focus has all changed. There's lots and lots of science being thrown at new material technologies, lots and lots of research being done to reduce complexity. And it's in the throes of being done. Some things are out in the public, some things are hidden away in labs, in universities, and in industry. But I can assure you that from a manufacturing point of view, we are looking at any material that reduces complexity, that removes material, that ensures its recyclability, and meets our public sustainability pledges, but also really makes the use of the technology in the right way. And we have technology that is ready to go. Nobody will ever buy it because of the cost of it. So there is a journey to go on from pure research to make it commercially viable to bringing it to the market. But believe me, every industry is looking at alternative materials.
I think the only thing I would add is that if we're serious about a circular economy and plastics, then we need to design plastics for recyclability. So we clearly need to be thinking about how we design both the plastics and the composites that the plastics are part of, so that they will work in whatever recycling processes we're looking at, one of which I described. I mean, to give you one example of a problem that I hadn't really thought about until I came across it. Bromine is a problem in plastics because bromine's a component in fire retardants. Well, we want our plastics to be fire retardant. And no doubt nobody thought about the recyclability issue when they started putting bromine compounds in there. But somebody's going to have to come up with a different fire retardant that doesn't have the same recyclability problems.
And I'll just add one thing as well, especially for pharmaceuticals, food use, cosmetics. There's lots and lots of regulation around a lot of these products. And we can't design materials that have any risk to the consumer. And the costs of getting it wrong are so big for our business that we spend millions of pounds looking at materials to make sure that the materials hit all the sustainability requirements, but also are safe to use, and make sure that they comply to regulations, not just here in the UK, but worldwide. So that there is a process to it, and the material and the sustainability of that material linked to the consumer is the core to it. But end of life as well is vitally important now.
Thank you to you all for your comments. I'm sure that both Stefan and Natasha could come in on these points as well. There's an awful lot to consider around them, and that's why we're having 2 more webinars coming up on the 5th and 11th of November, where we'll continue to discuss the issues and complexities surrounding plastics, their use, their disposal, and what is limiting us from making the step change that I think as consumers we all want to see happen. Please do feel free to join us. We would encourage you to do so. I'd just like to thank all of our panelists today for their presentations and their comments afterwards. I think we've opened a can of worms here of discussion, and hopefully you start to see how complicated the problem is, and hence why we've brought together the Birmingham Plastics Network to look at every conceivable different angle of the problem, from the technical to the social to the economic and significantly beyond. Thank you for joining us.